So the reason you're all here is actually to listen to Philip. Philip is amazing. I have had the great pleasure and honor of knowing Philip, I think, since his graduate student days. Philip has had an interesting and circuitous path to get here, which I think is true of many of the people here, starting off doing some very technical work in program analysis and verification-ish topics, and then moving and slowly morphing himself. He's everybody here at some point has probably used the Python tutor, and Philip is responsible for that. But I also want to bring attention to Philip's wonderful, wonderful paper, a retrospective on what it took to actually create and run the Python tutor as an academic, which I think is at least as impressive as the work in the Python tutor itself. But he's done a lot of work studying how programmers in different fields work. He's done really neat work on notebooks lately. Like, I don't ever run a grad seminar without reading a Philip paper, at least one, and usually many. So it's an honor to introduce Philip. Take it away, please.
Great. Thank you so much, Ram. That was a wonderful intro. And a lot of, most of that credit in the last few years obviously goes to my grad students who've really brought me into, some of them are here today, actually. They've really brought me into the world of data science and working with computational notebooks and things. And it's actually kind of relevant to this talk, but also kind of different. So, I was asked, when I was asked to give a talk here, I was asked to prepare an unconventional talk. So I've tried to do that, and we'll see, maybe I've gone too much in the unconventional direction. So this will not be a super technical talk. So, okay, title of the talk, teaser reveal is this. Okay. So we're gonna time warp back in time. So we're gonna not think about anything I've done in the last 10 years or so, which have been, reasonably successful. We're gonna talk about way back in the day. So I'm going to try to queue this up for 40 minutes or so. And then, like Ram said, if there are questions or thoughts, put them in the Slack. Okay, so git commit. Yeah, so organizers want me to commit to an unconventional talk. So this will be very much less polished than the usual research seminar talk that all faculty give whenever they get an invitation, right? So it's like the usually when faculty give invitation, give a talk, there is some talk that somebody, that they have prepared that is their latest, set of 3 papers or whatever. And that's all good and all. And those are usually very refined talks because they've given them dozens of times. But this is very much a one-off thing. I made this talk, I would probably not have a chance to give it again because it's such an unusual venue, which hopefully makes it a singular experience. Okay. So don't look at that. Look at this Slack chat. Yeah, I usually put this for people in Zoom, but don't go to Zoom, go to Slack instead. So yeah, definitely in the spirit of this, when I'm talking, if there's an interesting question you brought up, don't wait till then. You'll be, oh yeah, just write that in the Slack. So not the Zoom. So asynchronous is good in this way. So yeah, Slack is great. Okay, so who am I today? Quick, super brief intro. Let me actually start my stopwatch so I can keep track of the time. Okay, so who am I today? So this is 2022. So I'm currently an associate professor at UC San Diego, and I'm primarily in the cognitive science department, but I have affiliations in computer science and data science and stuff. So I'm part of the establishment, right? So I'm kind of middle-aged guy that's very establishment. I'm tenured. I'm at kind of a major US university, the usual boring stuff. I'm considered insider in HCI, right? I have all the publications and all the committees and all that stuff on my CV. They're I'm now having to write recommendation letters for people for various jobs and promotions. So I'm extremely established, very, very middle of the road establishment. I think I know PL and SE, software engineering stuff pretty well for an HCI person. I haven't been an active PL+HCI researcher for many years, but I think amongst people in the HCI community, I'm knowledgeable about it, and I'm also very interested in it. And I have some active collaborations with with PL+HCI folks, and maybe some of you in the future as well. So I think this would be a kind of a cool opportunity to open it up if y'all want to contact me afterwards and stuff. I think these are often really fun collaborations because people have certain domain expertise that they can bring to the table. And, that's obviously why most of you are here today. Okay, that's today, but let's go back to 2008. Okay, so what happened in 2008? So I was trying to find embarrassing pictures. So there was, remember when, when presidential debates were somewhat civil, I guess, in 2008. The iPhone had just come out a year earlier in 2007, and the App Store, I think, launched in 2008. So this is very early days of smartphones. And I guess this was the biggest movie that summer, right? There's also the, global financial crisis and everything. All right, so this is the context that I want to talk about in this talk. So that's who I am today. And who was I back in 2008? So this is like the mind space I want to like try to channel and get back to for the remainder of this talk. So if whatever I say, I want to try to channel my perspective of who I was back in grad school. So that I was, around a second or third year PhD student. I had been admitted for PL+HCI stuff. So my undergrad research was in software engineering. So like, when you apply to grad school, you're applying to an area usually, and, the advisors in that area take an interest in stuff. So I minimize the video. I was in kind of a PL+HCI group, but I definitely felt like an outsider in the area, and I kind of didn't get it, and I'll tell you what I mean by in a minute. I really wanted to pivot in HCI. Like I took an intro HCI course when I started my PhD. I know nothing about HCI. I started attending HCI group meetings and stuff, but I really had no way in there because like I wasn't like, people in that area weren't taking new students, like they were pretty in demand. So like the people they admitted were the students they're working with, and like I didn't really feel like I had a way in. So like I kind of felt like an outsider there as well. And I was fortunate to be on a fellowship for most of my time in grad school, which turned out to be really formative because I had a lot of freedom to kind of pursue my interests. I kind of work with different advisors and stuff. But the lack of constraints with the fellowship potentially is that I kind of felt a bit more adrift, and I didn't really feel like I had this home community as such. So this is the context, the kind of social context and psychological context I was in for the rest of the stuff. Okay, so here's what I didn't get about PL+HCI research back then. I mean, it's been 15 years, so this is it's good. I think some of you who've been in the field for a long time may have to check all this. So again, this is very naive view of someone who just started grad school in the field in the like mid 2000s. Okay, so this was my view of PL+HCI research back then. It was like everybody was in Eclipse. Remember Eclipse, right? It takes like 2 minutes to start up. So Eclipse was this big IDE for Java, and like basically this was like what enterprise software was in, right? There's like these JUnit tests and stuff, and people in the field were, a lot of people, people in my circles, mostly in SC, were making basically IDE and language extensions for enterprise Java. And some people were working for on C and C++ for more memory safety sort of stuff. Obviously, there's a lot of topics people were exploring, especially in the PL space, but I didn't have exposure to that, right? I was more in the software engineering and the applied side. So like my view of things from kind of the papers I read, the people I talked to, some of the conferences I went to, was pretty much like that was like the median sort of work was this. So here's my, a typical paper titles you saw back then. Again, this is not in the very theoretical PL, and this is much more on the applied SEN. This is be like typical paper titles you would see with something like this, right? Make this up, right? An Eclipse plugin and Java language extension for annotating unit tests to drive automated test case generator to improve code coverage on some set of benchmarks. So like I saw these sorts of papers a lot, and like when I was working in the area, like this was what mostly people were talking about. I'm just trying to give, this is kind of a cartoon figure, but like this was kind of the vibe. And even though I was I was kind of in the field and I was a student and everything, like I didn't really like kind of feel it in my bones, I guess. And the reason I didn't really feel this is because nobody I knew did this. like literally, I didn't know a single person who wrote Java code, who wrote unit tests, who used Eclipse, or who worked in these sorts of enterprise sort of settings, right? So like the people I knew worked in research labs, they were hackers, they were prototypers, they were designers, or they were startup people, right? They were building early web apps in startups. That's just not how we wrote code. Like I just could not relate at all to I guess the main target audiences for at least the kind of applied PL+HCI research that I saw around me. And like it was just hard to get myself motivated about the work personally, when like I literally did not know a single person doing this sort of stuff on the ground. And like and again, obviously there were millions of people back then who were writing enterprise Java code in Eclipse. Obviously there's millions of people there now, but it was just not the audience I related to. And it was just hard to get myself excited to work on longer term problems in that. So that's setting context. So how did I and everyone else around me actually write code? So this is how we wrote code, right? So we did a lot of hacking, a lot of prototyping, a lot of fast iteration. We built quick prototypes. We look at data, we iterate, we build web apps, like very kind of hacky web apps, or we built scientific scripts to produce results for papers and stuff, right? It's a very different style of programming than we see on the left side of your screen. We only use dynamically typed languages, right? I mean, like we never wrote any types at all, right? So, Python, Ruby, Perl was still pretty big, then PHP, obviously for early web apps, and JavaScript, right? So like that was the world we were living in, and we just did not see it really represented in the academic research of the field at the time. There was no IDEs, no testing, no enterprise stuff. It was kind of this like move fast and break everything sort of attitude, right? I'm not saying it was a good attitude, but that was the prevailing, this was kind of this two cultures that I saw, right? Like on one hand, there was this very enterprisey culture where, obviously a lot of this applied PL and software engineering work applied, right? If you're working on large code bases with teams and you want test suites and everything, but like everybody I saw around me was on this right end. And yet, this is what I really wanted to do, right? I really wanted to build tools to help people around me who were writing code to prototype, to analyze data, to do scientific research. And those felt like my people, but like just people in that field didn't really seem super interested. And again, like there were obviously people back then who were starting to think about this stuff, but I didn't have a lot of broad exposure because I was, I was still an early stage student. So like if those people existed, I didn't really know how to find them either. It turned out that there were people in those days in the HCI community who were starting to be interested in these things, but I didn't have very good access because I was very much in this PL+HCI world. And maybe this is, a discussion point nowadays, schools like this and also more awareness gets people talking together more, much more than it was 15 years ago. I mean, things were much more siloed. Okay, so when I talk to some folks about this, it's very, generalized, obviously. Kind of typical flavors of responses I get were, there's just kids playing around, not real software engineering that impacts real developers. Like if you look on the right side, this doesn't feel like software engineering, it doesn't feel like there's anything principled here, right? Like you can't really rigorously do anything, right? Because these are all dynamically typed languages. People are just kind of hacking around and stuff. It's hard to fit into this more traditional framework of doing more, statically based work. So, okay, so with that, I think despite the lack of enthusiasm people around, I still persisted on this path because because I had the freedom to, right? Because I was on a fellowship. I didn't really have to be bound by specific kind of projects that were more, grants based and stuff. So I kind of had the freedom to do this, which is great. But it also, led to have various angst and stuff. So, okay, so enough high level rambling. That was 10 minutes. I kind of capped my high level rambling 10 minutes. Let's just dive into one specific project. It's kind of fun because I haven't talked about this project in like 12 years or something because it wasn't super successful. So I like had to make this talk and read stuff over again. So if there are technical questions about this project, you can read the paper, but I like don't remember most of it. Okay, specific project. Okay, so thinking about the context we're just in. So, thinking about HCI, right? This is kind of very basic HCI stuff, right? Need finding, observation, user research. So I didn't know how to do any of this, right? Because I was not an HCI person, but I realized in retrospect that I inadvertently did this by like paying attention, right? Like I was genuinely interested in what the people around me were doing, right? Like the people who were doing scientific programming, doing computational work, building prototypes, like those were the people that I was always around, right? And those are the people I was interested in talking to. So I ended up just getting coffee with them. We ended up always talking about their data analysis workflows. I mean, the term data science wasn't really in use then, but essentially that was what they were doing, right? They're doing kind of these data science workflows and just looking at what they were doing on their computer. Like I was genuinely curious. Like I was very not curious about like, what people in a Fortune 500 company are doing with a 5 million line code base in Java, right? But I was very interested in what my friends and my fellow grad students were doing. So I inadvertently did all this HCI stuff without even knowing it. And I think that was what really got me interested. I'm like, oh, there was actually like a field of work where this can be more formalized. And I was just doing this, in my own ad hoc way. So this is what we did every day in grad school, well, more or less, when we weren't procrastinating. So when we were actually working, this is what we did, right? So we generate a bunch of experimental data, right? Or we extract data sets. So if you're a systems researcher, right? So like if you're working on networking protocols or working on, I don't know, like any kind of systems you research, for your experiments, for your paper, you are probably generating some data, right? You're simulating something, you are, creating a workload or something, and you just have a bunch of data, right? You're just putting in a little database or a CSV file or something, like when you're doing experimental work for your research, or you're doing network monitoring something, or you're extracting data, right? So, some of the early projects I did, we parsed like Git histories for, open source projects and bug trackers as well. So it's kind of empirical software data mining work. We're basically doing data sciencey things, right? You're getting data from somewhere, you're generating data. You're writing scripts. Mostly they were starting in Python at the time, like in my generation. And you're writing scripts to clean and wrangle that data, and you're transforming the data into different formats. And those of you who are doing empirical work should very much relate to this, right? You're taking data, you're writing some scripts to clean them up, you're kind of turning them into different formats, and then you're writing other scripts to process that data into human outputs, right? So you're making graphs, you're making tables, you're making, kind of printing out some numbers. And who is the target audience for that output? It's really your advisor, right? Like eventually it'll be going into a paper that you want to show more publicly or into a talk, but day to day, the primary audience is probably your advisor, maybe your lab mates, but probably your advisor, right? And you have this weekly advisor meeting where you're basically show your advisor what you did in the last few days. It's like, okay, like, we're doing, we're aiming for a networking paper and stuff. Here are our latest graphs, for our system. And then your advisor's like, wait, what about like this thing? Like you're measuring this. What about if you like split this up into like, I know nothing about systems, as you can tell. That's like, what if you split this up into, this protocol versus that protocol, and like generate different variants of your graph? And then they give you feedback, or they're like, oh, this is a confounding factor. You should really eliminate that part, and then, try to redo your analysis. And then you just loop back, right, to 2 or 3. And that's basically your weekly cycle. And you just basically are doing that week to week. If you're doing, this is in computer science, but if you imagine if you're in any other computational science field, this is basically your workflow. This is your life for like 5 years, 6 years, or whatever, as a grad student, and then as a postdoc or whatever. Like this is what we're doing. And like, and yet I saw very few people actually caring about how do we improve people's workflows that millions of people are doing in this way. So what was our main performance bottleneck? One could argue one bottleneck is that your scripts are slow and stuff, and yeah, maybe that's true, but it's much faster to write scripts in these scripting languages than like writing a C++ thing. But I think the main bottleneck is this, right? Is this iteration cycle, right? Is that your advisor would say something and be like, oh, why don't we just try this, right? And then like it takes them like 5 seconds to think of something, and then you're like, oh wow, this is going to take me a day to run because I need to like repartition my data here, or I have to like rerun this whole thing and like overnight and stuff, or I have to like wrangle my data in a different way and stuff. So this iteration cycle was a bottleneck I was interested in. It's because I faced this personally as I was doing empirical work. So how can we iterate quickly, right? So one way to iterate quickly, and I think people naturally do this if you're writing any set of data analysis scripts they're non-trivial. There's actually from my project MSR, I actually just, this is my make file. So the boxes, these are Python scripts. These are just scripts that do individual analysis, and the circles are data sets. So these are various input data sets. These are like from databases or from CSV files or from like, data dumps that people gave me. So I would process them, and then I would create other data files, right? So these gray ones are intermediate data files, right? That I would create. These are output data files or graphs or something. I don't remember what these were. And then, if you notice that this other script takes a bunch of intermediate data files and then another new one, and then generates another stage and then another stage and stuff. And the reason why we're splitting the stages is because each part of your analysis may take a long time to run, right? Like if this stage takes a long time to run, you want to save the results to a file because you've processed the stuff somehow, right? You don't want to just rerun it all the time. So you usually have one script for each stage of your analysis of your workflow. And that produces some output data file, which is basically to cache your intermediate results, right? You don't really care about these intermediate data files. You just need them so that you can feed them into the next stage. And then if your advisor wants you to tweak some later stage, you don't need to rerun everything from scratch, right? So if your advisor, so basically, this is the last stage of analysis, maybe these are graphs or something that go in our paper. If we just want to make, fine tune this one, like try this parameter, you don't want to rerun everything above it. So that's why you split them in the stages, and you like write a make file or something, or you use some other build system to put this together, or just manually rerun everything. Okay, so here's the problems, right? So there's some obvious problems with this, is that there's a bunch of files on your hard drive, and you forget which ones are stale, which ones go with what. You have to name them too, right? So you just have a bunch of files, like especially if you're iterating and you're doing different prototypes, you just have what are output intermediate _1 _2 _3, and then you like copy it to some _4, and you forget which ones you're working with, and then you're rerunning it on like old data that's stale, and then you have bugs. You forget which scripts to rerun, and then you might rename your scripts or rename your data files, and you forget which. It's just this like file and data management nightmare. You can write a make file for this if you're disciplined, but they're really hard to maintain because you keep on adding new scripts. Like this is just my end result, like the snapshot at the end, right? But as you're working, because you're trying all these things, you might be copying this script to another script, and then trying something else, and you often have variants and stuff, and it's just like a huge mess to maintain. Like this is just a huge code and data maintenance nightmare. Okay, so what do I ideally want? So this is what I really wanted. So I did this for a bunch. At my internships, I did this empirical data mining work, and I did work back in grad school in this, and I had other friends who did this too. So here's what I really wanted, right? I want to just write regular Python functions for my analysis, like just regular functions, because each step is conceptually a function, right? Or a set of helper functions to like take some data, do something to it, and just like save it. And I didn't want to have to create or manage any intermediate data files. Like I didn't want to have to deal with any of this. And I wanted a system that automatically maintained this workflow graph essentially, while still giving me the freedom to just write whatever scripting code I wanted, right? Remember like the workflow that we all worked in, like we're just familiar with tools like Python or Perl or whatever, because we can pull in libraries we need and stuff. Like there are these sorts of like GUI-based workflow visual systems for doing this sort of analysis work, but like they were very rigid, right? You have to work in the workflow. So I wanted to be like, give people the freedom to just write whatever messy scripts they wanted, and then to be able to have these benefits as well. So so this is the system I made. This is actually one of the first things I made in grad school. And it's called IncPy. So it's called incremental Python. So what IncPy is that it allows users to write their analysis stages as regular Python functions, and IncPy just automatically manages all of the dependencies and all of the intermediate data and everything. So it gives you this user experience where you're just writing code and just doing stuff, and then all this data management and caching is managed in the back end for you. So and it's all like all the gray circles in this figure. So essentially, if you were to use something like IncPy, you would just write your code as functions, and all these intermediate circles are taken care of. They're versioned, they're correctly maintained with all their dependencies, and all the stuff is rerun as you need it. Okay, so here's an overview of IncPy. We'll give a code example in a second, even though stepping through code examples and talks can be kind of tedious. But okay, so it's a drop-in replacement for it's Python 2. I had to look this up. This is Python 2.6. This was the state of the art in 2008 or whatever. Even though Python 3 came out in 2008, but like people weren't using it then. So yeah, so I mean it's obviously very old. Okay, so here's basically what it does, and it's a lot in here. So basically, when it runs code, it profiles which functions take a while to run, a few seconds, a minute, or whatever, what their code and data dependencies are, and if it's pure and deterministic. So I have this kind of wonky definition of purity. So purity means no side effects, except those we can memorize. So like, for example, if this is all in the paper, but like if your function like actually just prints a bunch of stuff to standard out, like we can just capture that as an output. It's like it's an output. So so we can say it's still pure, because if we capture that, we can replay that, deterministically. And then we have, we just kind of mark off random functions and stuff. So basically the idea that it memoizes your function inputs and your dependencies, your outputs to disk. It does this memoization, but it's persistent on disk, and it tracks the dependencies, and it's also automatic, right? So you don't have to say, oh, mark this function to memoize or whatever. Like you should just be able to write code as you like, and whatever can be memoized will be, and then it should transparently do all this. that's the very high level idea behind the system and the idea. Okay, so and what happens if you rerun your scripts in the future, it detects if each memoized function and its dependencies have changed. So, and if it hasn't changed, it just skips the call and it just reuses it from the disk cache. And this is usually very fast because we've only memoized stuff that's taken a while to run. And a while means, a few seconds or a minute or something. We're not going to memorize everything because most library functions are instant. So this is basically the win you get. You basically get, the same result, and it just runs really fast. And if dependencies have changed, it deletes the cache, it reruns it, and rememoizes it. So it's just like normal cache management stuff. And it automatically maintains this makefile-like thing for you because it's basically building up a dependency graph as your code runs. You essentially get a quote-unquote makefile, so that if you change one part of your code like this, only this part will rerun because it'll just reuse all the cache files from before. But if something up here changed, then it will, just rerun that branch and stuff. So that's the basic idea. Technical challenges, there's a bunch of, boring engineering details, but like the big one was that I wanted no user interface, right? Which I'll get to the HCI slides in a minute, right? I really I had this vision of a seamless user experience. Like I don't want them to annotate anything. I don't want to extend the language. I don't want to add anything. I just want people to be able to write Python as functions, like what I would think about when you're writing a data analysis. Just a bunch of functions taking stuff and processing it. Getting dependency tracking, this memoization to work, it was a kind of annoying because we have this flexibility in this language to do whatever you want, right? Like this is not a pure functional language. I wanted to make sure that it was safe, right? That we're encouraging people to write in this deterministic way, but you have utility functions, you have stuff that kind of messes with global state. We don't want to memorize those things because if we replay it, it would just weird stuff would happen. So we don't do anything super complicated, but still we wanted to do this tracking at runtime. All of this is done at runtime because the language is so dynamic, right? So that doing it static would be much harder. Also, I didn't know how to do it statically. And we wanted, implementation-wise, we wanted this drop-in replacement that especially worked with C libraries because people are using NumPy. Pandas didn't exist then, but NumPy sort of numerical libraries and stuff. A lot of reasons why people use Python is to import libraries that are essentially C extensions. And if you don't do this right, the C extensions all break. So there's kind of there's ways to extend the interpreter so that the C extensions still work. There's a lot of boring details in that, but I found that out the hard way when people weren't able to get anything working because their C extensions didn't work. But this was very important, right? The user experience is it needs to be drop-in replacement. You can't be just recompile your NumPy because that just doesn't seem reasonable. Okay, so let's run through an example. I know code examples are always kind of makes people's eyes glaze over. This is actually from the paper, so I simplified it. Okay, so what's going on here? There's a global variable here, so some global parameter. There's stage A, so this file has, imagine this is a file with a bunch of SQL queries. Every line in this file is some SQL query. You have a list, you iterate through the file, and then you run stage B on every line of the file. Well, there's a syntax there, yeah. So, if there's a bunch of lines, you run a stage B function, and then you make a list of, I guess, numbers or whatever. And then you run stage C at the very end to process this list, to do something more. And then after stage C, you return the sum of the list. And this is a toy example, but you can imagine this is kind of a realistic workflow. So that's stage A, and then let's go into stage B. So stage B is run on every line. So every line in this file has a SQL query, making up this code, right? So you open this database as database.db file. You execute the query, and then let's say you process this query for 1 minute, right? You're doing some kind of a non-trivial thing on it for 1 minute, and then we're going to return some result times this global multiplier for some reason, right? So this runs for 1 minute for every query because maybe your query takes a long time, or maybe after your query, you're munging the data in some way, calling external libraries, doing something for 1 minute. Okay, at the very end, stage C, is we're going to process the list again, right? So we collected all the stage Bs into a list, and then we're going to just do a bunch of processing again, right? So we're doing some more domain-specific processing. We're going to turn the result. Okay, so let's say you run stage A. I'm running. I don't want to run over time, but okay. So let's say you run stage A on a queries.txt file, right? So queries.txt, and queries.txt has 59 lines in it. So how long does this take? So stage A calls stage B 59 times, right? And that takes 59 minutes because 1 minute each time. Each stage B call takes 1 minute. And when stage B is running, because it's taking 1 minute, it's like, oh, this takes a while. Maybe we should cache this. And this is pure deterministic because it just has read dependencies on this, but it's like not doing anything to your global state. So what ends up happening with InkPy is that all 59 parameters, which are strings, I guess, is the string, right? This query string, and the result, whatever number or thing is there, we're all going to memorize that to a file. And the dependencies of this, of each memoized data is the code of stage B, right? The code object, of stage B, database DB, because it has a read dependency on that, and then multiplier, which is the global variable dependency. Because if any of these change, we can't reuse the result, right? If multiplier changes, obviously we can't reuse it. The database changes, we have to call it all off. And if the stage B code changes, it's call off. So dependencies are pretty coarse grained. They're at the function level, but they kind of do the job. Okay, after that, stage A calls stage C once, that's 1 minute. And then again, it memoizes, right? The list is memoized, and then the resulting list is memoized. And there's a dependency on the code of stage C. And then stage A returns some process. And this is memoized, and there's dependencies on stuff. This dependencies on queries.txt, because we did this on runtime. So we pass in queries.txt, and we say we have a dependency on the hash of the file or the timestamp. I think if we do it more like make files do. Okay, so this is a dependency graph. I didn't draw it out and stuff. It's in the paper. So then the total time 60 minutes, 1 hour. Okay, that's great. So then what happens if I just change the end of stage A? So basically, what's typical in these analyses is that this is just a sum, but imagine you do stage C and then you do something else afterwards, right? Your advisor is like, oh, I don't want the sum. I want the arithmetic mean, or I want the geometric mean, or I want the whatever, right? You might do some stuff at the end. And if you do stuff at the end and you edit it, then it actually runs instantly, kind of, right? Because everything is cached, right? Stage B is cached, all 59 calls, all 1 call stage C is cached. We just plow right through that function and just we don't run anything, and then we just rerun the sum, right, or whatever. So assuming this last part is fast, the stage A will run instantly, and that's the benefits you get, right? You're iterating this part. If this changes, nothing else above it has to rerun. And then this is useful because sometimes what actually ends up happening, because we do this all at runtime, a nice property is that if it crashes, right? So if you've been writing scripts before, I'm having like nightmare flashbacks. You imagine you're doing all this data processing, right? It takes like an hour, and then you have some bug here, and then all the functional languages and types of people like, oh yeah, you should have had types. But yeah, like a common problem with scripting is that you have some like type error here, or like some like a library throws an exception and stuff, and then you're running through an hour, and then like, something crashes down. You're like, oh no, I have to rerun my whole hour. But the cool thing is you can just fix a bug down here, and it just doesn't take an hour to run. But yeah, if we all use types, maybe that would be fixed. But we didn't, right? We didn't write anything with types. Okay, let's say you change stage C code. I mean, this gets kind of, so if you change stage C's code, then it only takes 1 minute, right? Because all the 59 calls to stage B are reused. So we're kind of pushing our way up the graph. So if we change stage C, then we only have to rerun stage C. And then you can imagine doing exercise everything. Okay, if you add a new query or edit an existing query, if you add a new query, it would memorize everything. You run stage B once for the new query, so it takes 1 minute. And then you have to probably run stage C again because the new query edited the list. So about 2 minutes. But if you change multiplier, right, then all bets are off, right? Because you have to rerun everything in stage B because it's a global. So like this will destroy all your dependencies and stuff. So basically, the end result here is that users just write their analysis as regular Python functions, and InkPy automatically manages all this. So you don't have to write any of the serialization code. So if we didn't have InkPy, what you would end up doing is you would end up writing code to like save this to a CSV file or a pickle file or something, and then load it from a file and stuff. So you would do stage B, and then you save them to a file, and then you load it from a file, and then you save this list to a file and stuff. This is a toy example, obviously, but like the benefits really grow as your analysis get more complex. So imagine copying and pasting a bunch of variations, right? You're like, okay, here's my analysis. What am I going to do? I'm going to copy it. I'm going to make another analysis. And it turns out there's quite a bit of sharing you can do, because while you're doing all these variations, it might turn out that these SQL queries are essentially the same queries, but you're doing a little post-processing afterwards. So that was a dream that hopefully that I want to make that. Okay, so enough about our project itself. I already talked for 30 minutes. I want to actually talk about the behind the scenes part, but I took too long for the code examples. Code examples are way back. Okay, let's go behind the scenes. 2008, 2010, I was a grad student. I was working on this. So like, what motivated me to create this project in the first place, right? And this is more relevant to all of you here. I'm just thinking about motivations and stuff, because this specific project you don't have to care about. Okay, so I spent the first year of my PhD like really working on traditional PL+HCI projects. We're doing like things like automated test case generation and other sorts of symbolic execution stuff. Like I didn't really make much progress. I felt pretty discouraged. Like it was a lot of work. It didn't really have much to show. I didn't actually have any papers out of those first 3 years of my PhD. I actually had some papers that it was like helping other people's projects, but like the main work I was supposed to be doing day to day, like I had no papers on like for 3 years basically. And I felt pretty discouraged. At the same time, I assisted on an HCI project actually. I can talk more about that in Q&A. And I was really hooked on it. I really enjoyed it. But I didn't know how to get into the field because the HCI faculty weren't taking new students at the time, right? Because everyone was pretty book full of students. But I was able to help out because I attended some meetings. I'm like, okay, like I'm happy to help because I'm working on my main project and I'm not really making any progress. So if I can be helpful in any way, interviewing people, doing observations. That's how I really learned HCI stuff, by helping out. But I wasn't on a path to be like an HCI grad student. So I wanted to develop my own project. I wanted to kind of merge some of these PL+HCI and HCI ideas in my own project. And it was possible because I was funded by a fellowship. But the downside, of course, like I mentioned earlier, is that no faculty really bought into my project or my ideas because I wasn't on anybody's critical path, right? Like everybody's lab has like, we're working on this thing, we're focusing on that thing. And I was just kind of floating off doing this thing. And like, it was fine. Like I was able to do it because I was self-funded. I TA'd a bit. I was on fellowship funding and stuff. And it was great. Like I was able to talk to people about it, but like no one really like cared, right? Because I was the only person who cared about this ink thing because like I wasn't part of anybody's like lab, right? Or any main trajectory. And I think, thinking back, I like, back then I was like very, stubborn and stuff. Like, well, yeah, I'll just do my own thing. But like, I do see now that I'm so establishment and I'm so boring, I do see a lot of benefits to being part of the critical path and being part of momentum and being in a group that have other people doing what you're doing. So, this is kind of a cautionary tale, right? Because I'm not trying to glamorize this. I'm like, oh yeah, everyone should go off on their own and do this because there's a lot of challenges. So what was my research strategy, right? Like people always ask me like, what is your research vision on this? Like I didn't have any, right? Like I really didn't have any at the time, but I did have this really clear vision of what I wanted to build. So I just spent a lot of time building it. So I spent basically a year on this probably. And I was just mostly just implementing and testing and getting it to work. So I had a clear vision engineering wise. I did a very clear vision like research wise, what I want to get out of this. I had 100% call a builder's mindset, not a researcher's mindset. So I was just like building every day. And I think for many PhD students might relate to this, especially in applied fields, like, building field may feel more fun than research, right? Because you're making this day-to-day progress where you're building out a prototype, you're testing it, you're getting stuff to work. And the research part is we have to try to write this in a paper. We have to try to pitch this more formally. We have to make a case for this and stuff that often feels very different than building. But obviously in the back of my head, I knew I needed to kind of get this published somehow to make a count to my dissertation. Like there's always this implicit, like papers are sort of the output a lot of ways. So I knew that I needed to somehow make this work. So I had to have some kind of strategy. And I really dreaded having to justify this as kind of a research thing, right? I was like, clearly there's something people wanted. Clearly there's something, there's some novelty here, but I really dread these conversations, right? So like I have flashbacks to this. Whenever I run into somebody in the department, people ask me, "Oh, what are you working on?" Right? Like this is like a casual question people ask, but I would just like elicit, just great pangs of fear because I've just described the system to them. Right? Like, oh, yeah, here's what I'm working on. Like I saw like people who are scientists who are working on this, and they were scripting and stuff, and they're like, and then we're just like, okay, this is like a cool side project. It's like a nice hackathon, but like, what's your real research about? Right? Like I hated this question. Right. It's like, oh yeah, what's your real research on? Like this thing's kind of fun and all. And then I would just like run away or something, right? Like this happened quite a lot. Right. And this is again a cartoon diagram, right? So kind of the more on the PL+HCI side, right? Kind of typical reactions to me talking about things like imply was, it's not a very complex technique, right? Like the technique itself, can be described on a page, there was nothing super formal about it. It seems like a lot of engineering, not much research effort. And okay, sorry, this is a, yeah, I'll leave that here. There are obviously some people who are interested in dynamic type languages then, but majority were not. And then how are you going to get this published, right? Like this doesn't fit into the schema of these PL or SC, even software engineering papers I see. Like, how are you going to try to get this published, right? And then on the HCI side, we have. So on the HCI side is I definitely found people who are interested in this sort of thing, but like just data scientists, data analysis, they weren't on their radar. Like it just was on the radar. And this is the asterisk. This is a few years before Jupyter Notebooks came out. And now like on HCI, like there are so many papers on Jupyter Notebook extensions. Like some of my students, I actually wrote a survey paper about this. There's just so many papers on Jupyter Notebook extensions for data scientists now. But back then, like nobody cared about this. Like it's like it seemed like a foreign world. But like they're like, yeah, this is kind of neat and stuff. But like that's just not what we're publishing papers on because it's in the 2000s. And then also there's no user interface, right? Like I purposely made this thing so it was a seamless experience where you're just typing code. There is no UI, right? There's no interface to this. That's the whole point. Like you're not trying to learn this new graphical programming environment. You're just writing Python code like you normally would write. And it doesn't feel like HCI projects feel, which is true because I didn't really have any formal training in HCI. So just like the way I pitch stuff, like it just like I had a feeling it was very HCI inspired, but like just didn't fit in the schema, which in retrospect totally makes sense, right? And again, how are we possibly gonna get this published anywhere, right? Like both sides said that because it's just it just kind of seems like this kind of hack in the middle. So to avoid these sorts of conversations, I really avoided going to the building for like a year. I just worked in coffee shops. I think that habit stuck because I continue working in coffee shops even when I didn't need to avoid people and embarrassing questions like, what are you working on? Or what are you really working on? And the only kinds of people who seemed really receptive were practitioners, right? Who really cared about it as a tool rather than judging as research. So like when I talked about this to people who were actually doing this work day to day, they're like, yeah, I totally get it, right? Like I totally get this. Yeah, I need this. I want this working. I wish this was a real thing. Like that was what I found a lot of motivation in, that like people actually really wanted this. So it really got me hooked on trying to make this work for real. I installed it on people's computers, tried getting it to work with libraries. So I spent a lot of time just getting this to work, like for real work. But largely it was a failure because it turns out it's very hard to get people to use a replacement for their interpreter, even if it tries to be as much a drop-in replacement, just because like there's going to be bugs, right? And like it's cumbersome. Also, like because this is baked into one version of Python, if you want to use a different version on their computer, you have to recompile it. It's a pain, right? Like deployment's really hard, and we can talk about that in Q&A as well. Okay, so building it was fun for a year. I don't want to go too far over time. I'm at about 40 minutes. So building was fun, but I needed to get it published somewhere, right? But there was no real market to get it published. So the kind of market at the time for papers, quote unquote, was, there was more of a functional languages focus in PL. And software engineering, there was more Java, C, C++, more of an enterprise focus. There was no focus on like people writing ad hoc Python scripts that didn't have typing annotations at all, right? The target audiences were often professional software engineers, right, for SC, and then the more PL research, you could say the target audience are developers of programming languages, or domain-specific languages. The ecosystem was very much around reliability, software quality, safety, and stuff, and that was what a lot of the work gravitated toward, which makes sense. And then evaluations were, proofs, you're doing performance benchmarks. They're not as user-centered. HCI, the market at the time was really on web development, kind of this web 2.0 thing, right? So that was where a lot of the center of mass was in the mid 2000s. So designers, web developers, starting to be mobile app creators. And then there were people interested in data analysis, but they're more like spreadsheet people, right? People doing spreadsheets, making these end user automation scripts and stuff, but not like, again, just writing Python code and like data. And you need kind of this hook to tie into design and stuff, which I didn't really know about. And I had no formal training in this. So like it was a big struggle for me to think about publishing this work, right? So my other project also were very similar. I kind of fell in between the gaps here. And maybe this is the cautionary tale, right? Like really fell in between the gaps. Like I just really was hard for me to think about how to write this work up as being in scope for either market. So how did it eventually get published? So first we did this workshop paper at this provenance workshop, which actually was very influential. So there's people who care about data provenance in the databases community, also scientific workflow community, kind of cared about this sort of work, even though it was not in my home community at all. So Margot Seltzer, who is very well known in databases and systems, she was one of the workshop chairs. She really took an interest in this project because her group was actually working on similar systems at the time of collecting kind of file and database provenance from operating systems calls and stuff. So people were kind of interested, but again, databases, data management, this was not my field. This is a third field that's completely separate that had no grounding in. But the workshop paper was really useful just for meeting people and stuff. So then to actually get this published in a conference, I aimed for software engineering conferences, because that's my only publication experience were in software engineering type conferences. So that was what I wrote it up for. I submitted to ICSI for first time. It was strong. I don't know if it was actually a strong rejection. I felt like it because I had no clue, right? Like I didn't know how to write this up. This is just me on my own trying to write this up. My advisor didn't really work in this area at all, so it was, it was what you would expect. I got it accepted ISTA the coming year or the next thing. It was great. It was accepted. I iterated on a bunch. I kind of refined the pitch. John Regier, who's pretty well known in software testing and the software testing and Twitter communities, he was a keynote speaker that year. That was the first time I met him. And he actually liked my talk, and he mentioned this on his blog. And this was a huge morale boost. I don't think I ever told John this, but I don't think I'll read his blog post. But like he actually read this blog post, and part of it, this is like a retrospective on going to the conference. He actually described the system like better than I could. Like this one page, I won't read it out. Like this is the description of the system. It's a great description actually of the system. So I was like, wow, like somebody, the keynote speaker of this conference actually took an interest in my talk and like wrote about it and talked to me about it. I was like, that was like such a huge thing for me. It was like, it was like huge external validation and stuff. So this is really cool. Okay, so the aftermath. Okay, I am almost at 45 minutes. Okay, so the zeitgeist is this like vague term about like the defining spirit or mood of some kind of time. And I talk about research communities having the zeitgeist, right? Like every decade or every few years, there are prevailing topics that people are just very interested in. And if you catch hold of those, and ideally you're on the leading edge of those, you'll probably have a more successful career. So like it really felt I had this relief to get it published, right? And I have this conference paper on this project. That's what like kind of counts, right? And then it also like with this external validation, like, oh yeah, like I worked on this for last year. It's actually a paper, right? It's like here's an actual paper. It wasn't just me like hacking around and stuff. And I also enjoyed writing up the paper and putting all the kind of all that knowledge I had in it. The getting to work for real users was kind of just engineering work, right? That didn't really count research-wise. Although I still was in this builder mindset, I still wanted to graduate and publish, right? I wanted to have some paper so I can say, here's my dissertation. I have a small set of papers and stuff. But it really didn't fit into the zeitgeist of the time, right? Of either in PL or HCI, right? So so like it never really took off like in that sense, right? And I didn't really pursue it either. Like it just was not the right time for that sort of work in that community. It's like the databases, the data promise community actually started taking off with this sort of scientific workflow stuff. But again, I was not in that community, but just in PL and HCI, from what I saw, it just felt like a dead end. More generally, I felt like I didn't fit in the zeitgeist, right? Of what just students in that either field focus on. So I didn't see a clear career path ahead for myself in the field either, because I was very much a one-off. Right. I just didn't see a path forward. So finishing my PhD, this is my last slide. I have some random other slides, but last slide, and then we'll go into Q&A. So I did InkPy, I did a few follow-up projects to basically on this similar spirit of helping people manage code and data scripting workflows. I published mostly at workshops, smaller conferences, kind of shorter papers. I never got this like, oh, here's the top tier paper at the premier conference that you give a give a job talk. But I never really had that like big home run thing. But it was enough to put together a dissertation. I didn't really feel a way forward for me to get kind of a full-time PI, faculty or research job, because it didn't really fit into this like market at the time for on either end. And I didn't have the skills or the clout to like create a new market, right? I mean, like, some people out of grad school, they are the leaders in creating this new market for things, but I just didn't have that basis at all. So then, basically what happening is this 10 years ago, my gosh, 10 years ago. So I defended my thesis, I graduated PhD, and I left academia, and I started a software engineering job, and that's the end. So now time for Q&A. So that is my last slide.
Wait, you can't end on that note because you're not in a software engineering job.
That's
right?
why we go into Q&A.
Okay, well, the speaker gets to decide when Q&A begins. So if that's is that a serious last slide, or is there like
Yeah, that's my last slide. I mean, I have some
Okay.
other slides about discussion points if people want to bring up points, but hopefully people have enough points to bring up that my scaffolding isn't needed.
Sounds good. I think there's also a few questions already in Slack, but let's do this. So we're going to go into breakout rooms. I'm going to put you in breakouts of about 5 or 6 people each. Please first introduce yourself briefly, get to know each other a little bit, but then we'll give you about 6 or 7 minutes after that to also talk. So your goal is to try to help understand the work a little better. In this case, of course, it's not just a work, but also like career related questions, etc. And do all of that. And we will also maybe just pop in briefly. We're not trying to surveil you. We're just trying to make sure we understand how the tone of conversation is going and if things are starting to die down or not. But either way, guaranteed in 10 minutes, we're going to bring everyone back together, maybe a little bit sooner. So, please make sure you stick around. So I'm going to start off the breakout rooms in just a moment. Okay, everybody, we are back. We would like to take your questions. Very simply, we just suggest you use the raise hands feature because everybody talking at the same time won't work out so well. So please use raise hands, and then we can just take people off in order on the list. So questions, please.
And usually you can find raise hands in that reactions on the lower right.
Yes, thank you. Ben, why don't you go?
Okay, hi, Philip. So I'm wondering if you could go back in time to that 1 year when you were working on InkPy, what would you have done differently?
Oh, wow. Yeah, I'm gonna try to concise answer. I mean, my quick answer is I don't think I would have done anything differently in that, I enjoyed having that sort of, the stakes weren't super high, right? It wasn't like, oh my gosh, I'm going to get kicked out of grad school or whatever. Like I was able to be funded. I still was able to do the work. So I mean, I guess the only thing I would have done differently is maybe talk to more HCI people about it at the time. So maybe that was the thing. I did give a talk at the HCI group lunch about it, which is good. But yeah, maybe just more less hiding in coffee shops and more actively engaging with more people about it. Maybe that would be the only thing. But in terms of the actual work, I don't think I would diverge too much. That's a good question.
Okay, thanks.
Mohammed, you had your hand up. Do you still have your question?
Yeah. So it's this is first.
Please keep your hands up, please, once you've asked a question. Thank you. Sorry, please go ahead, Mohammed.
Yeah. So sort of like one of the things that our group wondered was that why did you feel that for InkPy or in general, you needed to get into the HCI community itself to sort of like do your study or do your work around this? Because it seems like whenever you're working with something like programming languages, you're essentially working with humans at the end, or you're trying to improve the human experience. So by itself, it would seem that you do not necessarily need to be in the HCI community itself to just do the kind of research that you wanted to do over there.
Yeah, that's a good question. I mean, I guess I didn't feel the need to be publishing in HCI. I guess I still targeted these more software engineering conferences that's I was familiar with. I guess it was more like the HCI spirit, right? Just this idea of doing user observations and usability tests and case studies and deployments and stuff I thought was appealing, whereas a lot of the more software engineering papers you saw were more like performance benchmarks and test cases and stuff that were well, we had that also, right? We had we want to make sure in terms of this paper, you want to make sure the caching works and it's not super slow, and on a set of real scripts it actually saves you time and stuff. So it's not a great answer, but I didn't feel the need to all the way cross over, I guess, right? Because this work was still more software engineering-ish. So yeah, I would say I was more on the PL+HCI end still with this project than on the HCI end, but like I definitely wanted to cross over a little bit. There's not a great answer. We'll try to keep it short.
No, that's good. So Philip, I know that a question that has come up already in Slack, and I think certainly is on my mind, and I think on several people's minds is, so you painted this sort of slightly dismal picture, right? That you put in all these years of effort, at the end of which you had a workshop paper, and a workshop that, frankly, is a little obscure, right? It was kind of a new workshop, so it's not even like a prestigious established workshop that everybody already had name recognition with. And then, it's like looking at your slide here in 2012, roughly speaking, it's like, and then a miracle happened, right? So tell us a little bit about the miracle. So how did you go from several years of a quote unquote, formally speaking, unproductive line of work that you had difficulty getting adoption and so on? How did you get from there to, you're one of the leading universities in the US? Something's missing here in the storyline.
Yeah. I mean, I want to try not to go on too long about this. I mean, I think people could ask follow-up questions, but very briefly, the super TLDR version was that I think about zeitgeist, right? So the zeitgeist of the time around 2012 was around online education, and the MOOCs had started coming up. And these online courses started coming up, and there was starting to be this hype cycle built up around that. And then I worked on some of these educational tools, and I had also helped out on some HCI projects. So I had some like HCI papers that weren't related to my thesis work really, but there were other HCI type papers. And also the job market started opening up at the time because we had come out of 4 years of recession, and around 2012, 2013, a lot of openings opened up for software engineering HCI sort of jobs. So so then I applied for those, and I kind of put together kind of a case about basically data teaching programming and teaching data science-y sort of stuff. And yeah, so I didn't use any of this stuff in my job talk, this sort of scripting stuff. I had a paper about data wrangling that was at WIST. I had, some the early Python tutor stuff. And then, and so I got my first faculty position was at the University of Rochester. I was in for a few years. And then and I got a postdoc also at MIT the year after that. And then then it was fully into a different phase, right? So this last decade was, online learning was a big hype cycle. And then data science, obviously, that hype cycle started growing as well. And then basically, once I was in a position where I was post-PhD and I was able to have my own students and I was able to start writing grants and drive the agenda, then stuff started falling into place. And then, the UCSD is my second faculty position. So I applied again a few years later, and the momentum kind of kept going from that. So it's a very different story, but it was if we want to tie back to this story, it really was that, again, hindsight is always 2020, but the work that I did in grad school, really caring about people who were doing data analysis and scripting and stuff that really paid off, obviously, because now a decade later, a lot of people care about that now. And for myself, I had been thinking about this for many years, and it's luck too, right? If I had been really big on a certain other niche that may have not come out, then we wouldn't be here. So part of it is hindsight, and part of it was also capturing the wins at the time as well. But it's very much a singular story. It's hard to replicate, I guess.
So one piece of advice that a lot of people give is, pay more attention to the things that you find exciting or that you do, right? You had this beautiful thing at the beginning of your talk where, I was also part of the SE community at the same time, and going to these conferences saying, none of this resonates with me because I don't think I do any of the things that these people are talking about.
Right.
And so you followed your sort of your inner voice that said,
Right.
I have a feeling that there's this whole other side of programming that's being neglected, and you have to have a little bit of right place, right time. But you basically did that, right? I'm going to ignore these people and follow what I think matters. Yeah,
I mean, I think that was big. Of course, like all faculty
just
talks,
seeing your Java Eclipse IDE plugin thing just gave me bad flashbacks.
Very much, like all faculty talks, there's a lot of survivorship bias and hindsight bias and stuff. But it is true that, I still think I would give that. I mean, again, this is very faculty speak, but I still think I would give that advice that Shrim just said, because, if you're thinking about it in terms of what could happen, right? So if you're, again, to the best of your abilities, if you're able to follow that interest, one of two things happen, right? Like you hit upon something that you're in a growing area and you can build that successfully for your career, or you're not, right? But like the alternative is if you're actually working in an area you're not super motivated by, the chances are you're probably not going to make a lot of meaningful progress anyways. You'll probably have some papers, they probably be more incremental and stuff, and they'll be fine and you can graduate, but you probably won't be on that path anyways if you're not that super motivated day to day. So maybe the best play is, like Ashrav said, to really follow that instinct, because the worst thing that could happen is what would happen otherwise if you stayed for 5 years working on a project that didn't inspire you, right? So maybe that's the lesson here.
Right. You didn't talk about other career paths, right? So is it conceivable to you that you could have instead taken INCPI to, I don't know, create a startup or a product or something like that?
Yeah, that's a great question. I think Matt has a question also, but I'll answer that super quickly.
Yeah.
At the
Why don't you answer
time,
Matt's question first?
I mean, let's do Matt's and then we'll go back to the startup thing.
Please do.
Sure, yeah, thanks. Something our group, I think, talked a lot about was the zeitgeist idea as well as finding community. And I'm curious if you were able to find community elsewhere, and also given the fact that in 2008, the ways of finding community and online communities is very different from now. How has that kind of changed over your time as now you're here in 2022?
Yeah, I mean, I think that things have improved a lot, right? I mean, with programs like this and such. I think back then it was a lot harder. I also think, just myself right back then, like I wasn't the type to really reach out to a lot of people anyways and stuff. So it was, I think it's possible back then, but it just wasn't as easy. And yeah, in terms of, I mean, I guess the most, I really liked the INCPI project that we want to talk about because it did help me find other people who were interested in these sorts of things. So, I mean, I guess a really concrete thing that came out of this is that with this project, I was able to give talks about it. And that was how I met Fernando Perez at Berkeley. So Fernando is the co-creator of Jupyter, and he was the creator of IPython Shell back then in the day. And the co-creator of Jupyter project was obviously very influential. And he was in a research group at Berkeley then. And I gave a talk there, and he introduced me to people who were interested in this reproducible research thing, right? People wanting to reproduce research and scientific community. So I ended up going to some workshops on that. So that was really fun for me, even though, again, I didn't see a career path forward because I wasn't like in this like scientific programming area at all. But that was cool because of this project. I was able to meet people in that space. And again, the people in Jupyter are obviously very influential now in that space as well. So that was a positive side effect.
Elijah, go.
Sure. So, so you talked about like being in this like 100% like builder mindset, and like your project like sort of really like reflecting that, and still sort of like needing research like to come out of it because you still are a PhD student. What does it look like to turn that building into research?
Yeah, so I guess if I had one claim to fame of the last however many years, I think someone said this. It was actually another person who you'll probably know. They're in software engineering, and they're like, they were talking to me during grad school, and they were like, yeah, your skills seem to be, retrospectively turning these hacking projects into some kind of a quasi research thing. And I think part of this is I think a big part of this is finding the right venues, frankly, right? So I think that's why I gravitate a lot toward the HCI space, just for myself, because if you look at a lot of these applied HCI papers, they basically are doing user-centered research and making certain kinds of producty things for a certain population. And there's some kind of research spin on it, but like the research itself is more, I guess, identifying the problem and the population and having some kind of increment of progress on that. So, I mean, it's hard to prescribe a formula for this, but like, I feel like it's often doable if you pick the right community and venues, right? So like even in software engineering nowadays, in some more applied areas, I'm sure you can make that work. I think that people, I mean, fundamentally, in terms of like the meta game of research, in a way, it's kind of popping up even more level of people who are reviewing papers on program committees and stuff. I mean, frankly, now that I've been doing it for a while, and I think some of the other faculty, but really is that like, we just want to see interesting papers, right? It's like, we want to see papers with interesting results and interesting domains. And yeah, you have to have all the right pieces and stuff, and it has to be done rigorously and stuff. But like, I just think that those papers just stand out to us if we have a pile of papers to review. Like, if you're targeting a domain that's just interesting or emerging and stuff, like, like all of the hosts here have done, like, it just makes for a more inspiring story for people to see. And I think that, again, just personally speaking, the HCI world, I think we see a good amount of that because there's more of a focus usually on the domain and less on the like technical underpinning, right? And more on the like, is this actually an interesting domain that is growing and that people are interested in? I know these are super vague answers. I know. I'm trying to move to get more questions.
I want to ask a question that came up more as a discussion in one of the groups that I sort of popped into for a moment. I don't think it turned into a question, but if you're in that group, please feel free to hop in and sort of add to what I'm about to say. But I think they were reflecting that when they have that experience of feeling kind of uncomfortable with that "what are you working on" question, like you described, and almost sort of wanting to avoid those conversations, they're saying that they find that quite stressful to experience in their own lives, and how uncomfortable that can be. And so I wonder if you could say anything about sort of diagnosing, more about why that was happening for you, and if you have any advice for students now on avoiding getting into that mode, since it does seem to be something that is quite stressful for folks.
Yeah, I mean, this is the more general question here now that I've been faculty for a while, is just that like, it's just kind of things that faculty or people in positions of power say, right? Even without bad intentions, right? It's like it's not like people have bad intentions or anything. But yeah, like I think that on the faculty and kind of trying to put yourself in the mindset of someone who's just starting with new ideas and stuff is important. I mean, I guess on the student side, how to work through that. I mean, I think perhaps one way is to talk to different sorts of people, right? Like that you will find somebody who is in a position of authority who's excited about the project because they're maybe in a different field or subfield or a different thing. So for myself, talking to these people who are in the data provenance community or the scientific programming people, they were really excited about it, even though they're not in my home community, right? Like they wouldn't be able to help me get a PhD or publish or whatever, but they were interested in it and they were doing the work. Yeah, I think it's tough. I think these early experiences are tough, especially, I mean, this is another story that's kind of related actually. So like, I guess is related to the very beginning story of when I was really thinking about these ideas and talking to people about this early on. And again, it was my choice of people to talk to, also just the people around me. But like, I did feel like, in retrospect, it's understandable because what I was pitching and those things that just didn't fit in at all with what the research community was doing at the time. I would imagine if someone, imagine if there was a undergrad or a master's student coming up to me and saying, "Oh, I want to, work on a Chi paper about this thing," and then my gut reaction would be, okay, like it's gonna be really hard to make this into a Chi or a WIS type paper because it just is so far out of the realm of what the papers we've seen are, and like how do you encourage them or how do you get them to pivot their idea and stuff? It's very tough, and I think typically these interactions may not go super well because it's just people's gut reactions. And I now that I'm on the other side of the coin, I don't fault people for potentially being dismissive of that just because it's just like, it just seems to fit so far out of the schema of what we know, but I don't have a great answer to that. All right.
That's really interesting, this idea that maybe this is actually the people you're talking to sort of trying to be protective of you and trying to steer you towards something that's going to make you successful, but then maybe having this sort of
I think if viewed in the most, viewed in the most positive light, I think that is true. I mean, obviously there are going to be people with a chip on their shoulder and kind of being snarky and stuff, but I think even the conversations I had with people who were supportive, now I'm thinking back, I think that like, I think they were thinking like, okay, like if you want to start a PhD in this area and you want to get through the program and get kind of, build up a portfolio paper and stuff, like it seems really hard to do this thing that you're proposing, and there are other paths and stuff. So I think that makes sense.
That might be positive in terms of the people's intention, but it says something really negative about our field.
Yeah, we want to be open to exploring those new ideas and new areas, right?
Yeah, I think this hard. I mean, I don't think it's an indictment of any particular field. I think it happens everywhere, right? Because whenever you have specialization and when you have communities of practice, like there is going to be, I mean, this is not just in research communities, in any kind of, open source communities or hobbyist communities and stuff, there is this in group and there's this, it is a community of practice. So there are these conventions and there are insider and stuff. And like you want to balance this need for inclusion versus having a group identity as well. So it's very hard. Like that is like a very difficult thing to traverse. And I think that, as people in a more senior positions, as faculty, we're able to, one way to traverse this is that we have this portfolio, right? We have certain projects that are more mainstream, and then we have other projects that are a bit more farther out and stuff. But that at the junior level is very hard to do that because you probably only have one project you're really focusing on. So that bootstrapping problem is really hard. And I think without going on for too long, I think a hard problem, I talk to this with my students too, is that like, it takes, let's say it takes like, this is like the whole 10,000 hours thing, and it's very overdone. But I do think that like, let's say it takes you 8 or 10 years into research to really get your footing in somewhere and to start doing stuff. But the problem is your grad school is only around 5 years, right? So I think that like everybody's hitting that cliff by 5 years. Like I personally didn't until, the 8 to 10 year mark start getting everything or getting things. But like most people at that 5 year mark, you're pretty much cut off. If you don't make enough progress in that first 5 years, you don't get that next 5 years, right? And so then the strategy is, how do you get enough incremental progress in the first 5 years, you can get another 5 years. So you can get to that point where like, oh, I see how pieces actually fit together. I don't know. I mean, I don't want to say that, I don't want to say that PhD should be 10 years, right? That would not be good. But that it does, I do definitely see that there are students, many students I see where at the 5 year mark when they're about to graduate and I got to graduate, I want to get a job and stuff because my friends are all graduating and stuff, like I'm like, wow, if you just had a little more time on that momentum, you could really be onto something. And that's why people get postdocs and get stuff. But then, you don't want to stretch that on too long either. But that is a dilemma I constantly see, that like it just, that time span, especially now as research gets more complex and more interdisciplinary and stuff, that time span of training just takes longer. And most PhDs, are in that 4 to 6 year range. You like, if I had just left like at the PhD mark and I had been in industry and stuff, I would have never gotten to that point where I'm like, oh, I actually like really get this now and stuff. So I don't have a great answer to that, unfortunately.
Well, I think that's a great place to end the kind of formal speaker session. Thank you so much, Philip, for joining us and sharing some really vulnerable stories about how you grew up as a PhD student. And I'm really grateful to have you as part of our community as a tenured professor, looking out for folks now. So
And inspiration. Yeah.
yes. So I think with that, the formal organizers will leave, and Joe and Justin are going to take over, and y'all have some fun. We'll see you tomorrow for yet
All right,
another.
awesome. Yeah, and feel free to reach out on email if folks are interested in anything follow up. So yeah, this is really fun. Thanks a lot.